Hi everybody, Mrs. Pesic here. We are looking now at graphing quadratic functions. This is from Chapter 4, and we are going to start with graphing quadratic functions that are in standard form. So let's take a look at the big ideas from this section. You should be able to graph and write quadratic functions in several forms, solve quadratic equations using a variety of methods, and perform operations with square roots and complex numbers. Those are the big ideas for the whole chapter. So let's start with graphing a quadratic function. Y equals ax²+bx+c would be the general form. And what shape would that have? If you say a parabola, well done, that is correct. It will have a shape of a parabola. So what's the basic shape look like for a parent function, y equals x²? So again, this is the general form right here, y equals ax²+bx+c, and but the parent function would just be y equals x². So if we were going to complete the xy chart and plot points, then we would see that -3 squared, that's -3 times -3, that's going to be a +9. So let's plot that. So -3, 9 is right here. And -2, I hope that you're graphing this also on graph paper. If we plug in -2 for x, we're plugging things in for this x right here. If we plug in -2, then we're going to get a +4. So here's the ordered pair -2, 4. If we plug in -1, we're going to get -1 squared is 1, so that's right here. If we plug in 0, 0 squared is 0, that's right here. If we plug in 1, 1 squared is 1, so that's the ordered pair right there. And 2 squared is going to be 4, and so on. And so the graph is going to end up looking like a nice round bowl shape. Parent function of the family of x equaling x² is going to be a parabola as shown below, and this is in your book so you can check this out. The lowest or highest point on the parabola is called the vertex. So the vertex for our parent function is right here at 0, 0. There is an axis of symmetry. We'll divide the parabola into mirror images, and it always passes through the vertex. So here's your axis of symmetry for the parent function right here, and we can see a mirror image one side as the other. So to highlight, the axis of symmetry for our parent function is x equals 0, and the vertex is the ordered pair 0, 0. Alright, so the parent graph, y equals x², has a graph that is a parabola, and it opens up and has a lowest point called the vertex. So what is the vertex of the parabola, y equals x²? It is 0, 0. Alright, so let's look at a few different quadratic functions. Let's start with our parent function, which is right here. There's our parent function, y equals x². And just like you saw from our discovery lesson the other day, if the c value goes up, we're adding x² plus 3, x² plus 4, x² plus 5. We can see the graph is shifting up. Same thing if we make the c, well, we're calling it c here, we were calling it k before. It will shift it down. That's if something's being added or subtracted at the end. But what about, back to our parent function, what about if the a is positive? Then we've got 2x², 3x², 4x². We can see that the graph is getting narrower. All right, take that one piece at a time. So it's kind of a nice little parabola grapher that we have here. All right, so the lowest point of a parabola that opens up and the highest point of a parabola that opens down is called the vertex. All right, so if your parabola opens up, then that vertex is the lowest point. If your parabola opens down, that vertex is the highest point. All right, to find the x-coordinate of the vertex, use this easy formula. Get this written down for sure. The x-coordinate of the vertex is -b divided by 2a. That is in the x-coordinate of the vertex, we just take -b over 2a. All right, so let's try that. Find the x-coordinate of the vertex of the graph of this parabola. Well, again, we want to use -b over 2a. And so we're going to take negative 6 over 2 times 3. Looks to me like we get negative 6 over 6, which is negative 1. So the x-coordinate should be negative 1. There it is. The x-coordinate is negative 1. How do you find the y-coordinate of the vertex? You plug the x-coordinate back into the equation. So let's find the y-coordinate for that vertex that I gave you above. So if we're going to plug in negative 1 here into this function to find the y-coordinate, we're going to have y equals 3 times negative 1 squared plus 6 times a negative 1 minus 4. And that's going to give us 3 times a positive 1, that's 3, minus 6, minus 4. So we end up with a negative 3 minus 4. I'm thinking it's going to be a negative 7. Let's see if that is correct. Yes, it is. Negative 7 is the y-coordinate. So the vertex is negative 1, negative 7. So that's how you find the vertex, the very important vertex for a parabola in standard form. Alright, parabolas of the form y equals ax²+bx+c have a vertical line of symmetry and always goes right through your vertex. So our vertex for our parabola is here, and our line of symmetry is right here. Alright, so what is the ordered pair for the vertex above here? This is 5, 3 to me, if I'm looking at that correctly. Yep, 5, 3. So what's the equation for the axis of symmetry? So what's the equation of this vertical line that goes through that point? All of the x's on that equation are 5, so that's going to be our equation, x equals 5. Okay, so here is a little summary of the properties of the graph of y equals ax²+bx+c. Notice, please, that if the a value is greater than 0, then this parabola opens up, right? And if the a is less than 0, then the parabola opens down. And also notice that what is the axis of symmetry is always going to be x equals negative b over 2a. So that's a very important formula for us. So what are the characteristics of these graphs? We just said the graph opens up if a is greater than 0 and down if a is less than 0. And as we looked at with our little grapher, the graph is narrower than the graph of y equals x squared if the absolute value of a is greater than 1, and it's going to be wider if the absolute value of a is less than 1. We can find the axis of symmetry by taking x equaling negative b over 2a, and we can find the vertex by finding the x-coordinate first, which is negative b over 2a. And then lastly, the y-intercept is going to be the value of c, so the point 0, c is on the parabola. So going back to this example for a moment, this example here, if we're looking at this, you can tell that the y-intercept for this graph is going to be what? We found the vertex. The vertex turned out to be negative 1, negative 7, but the y-intercept is going to be just this c value right here. So that's negative 4. So the y-intercept. Alright, so we are looking at quadratic functions, and they do come in 3 different types. They're standard, that's this one, and then we have vertex form, and then we also have another one that is intercept form, but we're going to not worry about that one for right now. So first of all, highlight what are the steps for graphing a quadratic function in standard form. So our first step is to decide if the parabola will open up or down. Do you remember what we look at to decide if it opens up or down? That's when we look at the a value. If a is greater than 0, it's going to open up. If a is less than 0, it's going to open down. All right, our second step is to find the vertex. Do you remember the formula for finding the vertex? The formula for finding the vertex is negative b over 2a. That's to find the x-coordinate of the vertex. All right, that's step 2. And then you do want to find the y-intercept. Do you remember how to find the y-intercept? That is when you just look at this c value right there. That's going to be your y-intercept. Next step is to find the symmetry point. That's going to be the point across from the y-intercept. So we're going to look at an example of how to do that in just a moment. And then lastly, you're going to plot all of those, the vertex, the y-intercept, the symmetry point, and then connect these points with a nice smooth parabola shape. And those are your steps for graphing a quadratic equation in standard form. Alright, and we are going to look at how to graph these on a calculator also. Alright, so let's say we're going to graph this not on a graphing calculator first, but just by hand. Alright, let me pull up a... First step, remember, is to decide if it's going to open up or down. Alright, it is going to open up because we see that our leading coefficient is positive, so it is going to open up. And so we need to find the vertex. And so in order to find the vertex, we want to do negative b over 2a. So let me first write down what we know. We know it's going to open up. And the vertex is negative b over 2a. So in this case, that's going to be opposite of 4 over 2 times 2. Right? Because this is our a, this is our b, this is our c. And so that turns out to be negative 4 over 4, which is negative 1. Alright, that's our x-coordinate of our vertex. So we know our vertex is negative 1 comma something. And we're trying to find that y-coordinate. Question mark there for right now. Alright, and so to find that, we need to plug in this negative 1. And we're going to take that negative 1 and we're going to plug it in wherever we see an x in our equation. So that would be right here, that x, and right here, this x. Write down 2 times negative 1 squared plus 4 times negative 1 plus 3. So negative 1 squared is a positive 1, times 2 is 2. So I've got 2 minus 4 plus 3. And that's going to give me a negative 2 plus 3 is 1. So my vertex, and get rid of my question mark now, my vertex is going to be negative 1, 1. So here's my vertex right there, negative 1, 1. I can plot that. And I want to find my y-intercept. Y-intercept is just going to be this c value right here. So I know that I have a y-intercept here at 3. And I can draw in my symmetry line. Let me just write down that my y-intercept is 3, and my symmetry line is going to be this line right here, okay, that goes through the vertex. And so that equation for that symmetry line is going to be x equals, because it's a vertical line, x equals negative 1. Remember, it's x equals your negative b over 2a. So now we want to find the symmetry point. As I was saying earlier, that symmetry point is going to be the point that start yourself out at the y-intercept and say, how far do I need to go to get to the axis of symmetry? Well, I've got to go 1 unit over. That means I want to go 1 unit past that and end up right here as my symmetry point. Those points are equidistant from the axis of symmetry. So my symmetry point is going to be negative 1, 3. Alright, and so at this point we have found the vertex, we found the axis of symmetry, we found the y-intercept and the symmetry point. So let's draw in our parabola. It looks something like this. Alright, it looks like this. It might be good to have 2 additional points to plot so it doesn't look quite so sloppy. And so that concludes how to graph a quadratic function that is in standard form. Please check out the next video on how to graph quadratic functions in vertex form and how to use the TI-Nspire to graph these. Thank you very much. Hope you took good notes, and don't forget to write down 3 questions from this video.